Shall we start? All right. So good evening, everyone. Welcome to the technical session 4 of day 1 of National Convention. So I am here to moderate the session. I am Dr. Vandana Khanna from the North Cap University. So I invite Dr. Jagtar Singh as session chair, who is council member of II. Thank you so much, sir, for coming and taking out time. So we'll start with the sessions. The number 1 is paper ID NCET 03. The title is Geometry Optimization of Interdigital Capacitive Sensors for Enhanced Dielectric Detection in Frying Oil Quality Assessment. So the authors are Shelza Jain and other members and team. Are they ready?
Good evening, everyone. So I am Vishal Dixit with my co-authors Dr. Shelza Jain and Dr. Shakshi Bangya. My presentation title is Geometry Optimization of Interdigital Capacitive Sensors for Enhanced Dielectric Detection in Frying Oil Capacity Assessment. So these are the content outlines of our presentation: introduction, literature review, microfluidic sensor design and principle, methodology and solution setup, result and discussions, conclusion and references. As everyone knows, frying is most widely used cooking method in restaurants and others. However, frying oil becomes toxic when used continuously. So, a reliable and timely assessment of frying oil is important, so as to mainly consider the human health. So, for this, microfluidic technology is becoming most popular for this purpose. So, we have designed. The capacitive sensors based on interdigital electrodes for this purpose. When we continuously using the frying oil, it will release the polar compounds, which is toxic for the human health, as well as it have other adverse effects also. Hence this our paper is focusing on the design and analysis of interdigital electrode-based capacitive microfluidic sensor crafted for frying oil quality assessment. Hence, the main objective of our work is to identify the design rules that increases the sensitivity to dielectric constant variations. So, further concluding, these are certain These are certain research literature reviews. As microfluidic lab-on-chip devices have been widely explored to condense the standard analytic procedures. Various microfluidic systems have been developed. However, their fabrication cost is high. Various low-cost fluidic sensors are also developed. However, they possess less sensitivity for this purpose. Paper-based microfluidic sensors are also developed. However, they have less durability in this purpose. Also, various electrochemical methods such as titration for free fatty acids, measurement of peroxide values. These are certain methods used for this purpose. So, however, this paper provides systematic geometric optimization of ID-based sensor integrated in microfluidic configuration. These are the microfluidic device design and principle. Microfluidic platform. This is the basically platform on which we have developed our sensor. So we have used glass and silicon. Polymer based upon PDMS, polycarbonate, PMMA, and we have also used the paper for the substrate. Interdigital capacitive sensing principle. Our purpose is basically on the capacity sensors. So we have used altered comb-like electrodes printed on a planar substrate. The main principle is that effective capacitance between two terminals of if I'm talking about a capacitor, depend upon several parameters. Basically, as you know that capacitance is equal to epsilon naught A by D, where epsilon is permittivity, A is area, and D is distance. So our design objectives is high sensitivity to dielectric constant, which means कि dielectric constant पे वो अच्छी sensitivity provide करे. Linearity and use strain conductances. It will provide linearity to our sensitivity, compatible with measurement hardware, which is frying oil in this purpose. This is the layout of an interdigital electrode, in which you can see comb-like structures between the electrodes, and this is the substrate as we have talked earlier about, and this is the basic layout diagram. This is the finite element model. We have developed an interdigital electrode in a console software, which is a finite element analysis software, in which just like we use PI twinning. KP and KI values using different values so that compatible for the application. This is the sensor geometry of oil capacitor, as you can see. This is the substrate comparison. We have mainly used three substrates: PTFE, FR4, and glass for the material. These are our resultant discussions. Concentrate, which means in oil is working as a oil is working as a medium for the capacitor. Hence, जो हमारी जो फिंगर्स हैं सिंपली जो इसमें सेंसर में जो हमने बनाई है उसमें इलेक्ट्रिक फील्ड हमारी कंसंट्रेटेड है प्रॉपरली, और मतलब एक्साइटेड फिंगर्स के बीच में हमारी हाई पोटेंशियल अकर हो रहा है विदाउट एनी प्रॉब्लम. And as you can see, the capacitance exhibits a linear relationship. Let me show you in the left slide. These are the results for the sensor permittivity versus capacitance for different substrates. This is for when we use width equal to 0.5 mm, and this is for the result when we use width equal to 0.1 mm. These are the computed sensitivities with different geometries. This is the size of the sensor, this is the width of the sensor, and this is the length of the sensor in mm. And these are sensitivities with different substrate: FR4, TFE, glass. Sensitivity results also shown that sensitivity also vitally unchanged, means which is providing a linear behavior in the system. Total capacitance decreases for narrow layers, which means very thin layers is provides very less sensitivity. And these are the implications for system. These are the conclusions of our paper, design simulation optimization conclusions, and results show that our sensitivity is varying linearly with capacitance, as is shown in the graph results. Low permittivity yields, which means when we have less permittivity, it will yield higher sensitivity. Also, substrate and oil thickness have less impact on sensitivity. These are the certain references we have used. Thank you.
Queries from the session chair and others?
My question is, how do you optimize the dimensions of this capacitor?
Sir, basically our system is simulation based. We have developed our system in console software, which just like MATLAB is a math software, console is a physics software in which we change the dimensions of of our capacitor. As you can see in the results also.
It is the different element, but there are different.
No, sir. It is something like different from which finite element analysis method.
Tell me the name of different optimization techniques that are available with us. There are some optimization techniques.
Yes, sir.
Tell me the name of those techniques.
Right now, sir, I am not able because it is our pre-work, and so that I am not able to explain it.
Do we have to do the genetic algorithm, particle swarm optimization?
No, sir. It is something different from that optimization. It is just finite element analysis method.
It is the simulation only.
Yes, sir.
You have not done any mathematical work.
No, sir. We have not developed any hardware yet. It is a future scope to develop it.
Mathematical work. Any mathematical work you have done. Only simulation. What are the different dielectric materials available in the market?
Sir, basically we have that material we have used is basically three PMMA, polycarbonates and PTFE. These
The full form of PTFE.
PTFE poly. Excellent, sir. I have written that.
What is the value of dielectric constant for FR4 dielectric material?
Is that any value?
Practically, ਜਿਹੜਾ FR4 material ਅਸੀਂ use ਕਰਦੇ ਹਾਂ, what is the value for the dielectric constant?
I'm sorry, I'm not able to answer right now.
What are the different parameters that affects the dielectric constant of the?
Sir, basically capacitor width, capacitor length, and all the parameter related to capacitor affects the dielectric constant of the material.
Can we conclude? Yeah. Thank you. Good. So next is taken from session which was tomorrow actually. So they have requested. So author has suggested requested for today. So the paper ID is. Yes. So we are taking one paper from technical session 5 to today, which was scheduled tomorrow. So as per the request of the author, we are taking it today. So NCET 01 is the paper ID. The paper details are behavioral insights for IoT enabled energy conservation and sustainability. The author is Dev Kumar Jaiswal and team. So you can start.
This slide will move from this. How this slide will move?
Ask them to.
किससे?
Just a minute. अच्छा off है क्या? इसे off on कर देना.
Yes, now it will
ये
move.
on है. Now it will move. बैटरी वो तो नहीं है close के. बैटरी को लगा सकता है.
एक ले दो फोटो. निकाल दिया था डोंगरी निकाल दिया अच्छा बट ये हो रहा है मूवमेंट तो ओके ठीक है थैंक यू
Good evening all, and thanks for giving me opportunity to present my paper. So I am doing research on energy conservation and sustainability. So I think that is good platform to present the paper, our research paper. So my topic is behavioral insight for IoT enabled energy conservation system. So I'll be covering the stacked agenda. Then I'll talk about the what is IoT, basic of the IoT. Then we'll talk about the literature review, how this research I have done. Then thereafter research, what was the research objective and hypothesis. Then methodology, which methodology I have used for this research. Then finally key results for both TAM and for ELS conclusion. Yeah. Yeah. So abstract of paper, IoT for energy efficiency, how smart sensor and cloud system optimize energy consumption. So what is the purpose of this study? The purpose of the study to know the behavioral aspect of the human being for the energy conservation. Then framework which used, that is the technology acceptance model TM and the energy literacy scale. These are the used for the framework used. Then method is this quantitative survey, and the focus area was for the survey, and then expected outcomes of this that which age group they are more sensitive towards the IoT. Yeah, so technology. So technology alone cannot deliver sustainability. Human behavior complete the equation. The research reveals how age, perception and energy literacy shape IoT-driven energy conservation. So let's understand basic of the IOC for electrical engineering. So what is the basic of IoT? So if any device is connected through sensor and through internet, this is called the IoT. What's happened? Yes. So device collected, share and act and real-time basis, enable automation, optimization and remote control, used widely in homes, building and industries. How IoT improves efficiency, real-time monitoring of energy consumption, automated control of lighting, HVAC, pumps, motor, detect energy wastage through analytics, predictive maintenance, reduce downtime and the cost.
You are a B.Tech student or M.Tech student?
No, basically I am 25 years of experience and I have done MBA and pursuing PhD. So for PhD I am doing research, so I am presenting my research paper. So I am working in industry.
Try to improve the presentation skills.
Here this kiosk, nothing is working. So yeah, so type of sensor which are used, the temperature humidity sensors which we use for predictive maintenance, HVAC optimization, ambient environment sensor, that is for the air quality, vibration, noise, flow meter, water, gas, industrial fluids, smart power meter for load monitoring and energy profiling, occupancy and the motion sensor, smart lighting we have seen many places when we go, the light will switch on, that will go about, the lights will switch off. Pressure and differential pressure sensor, ventilation boilers. Yeah.
Have you done
So,
any work?
sorry.
Have you done any work?
Yes.
Come on with that one.
Yeah. So through this, basically for this, how this works in the electricity. So in electricity, what are the main things? The bus bar joint, the cable joint, the transformer. These are the main things where we can put the sensor and we can enhance the life, predictive maintenance, energy conservation through the sensor and predictive maintenance. So efficiency monitoring and this critical connection 24/7 monitoring based on the vendor expertise, immediate alarming and schedule. So I'll come direct on the which work I have done. So you can do the slide, you can run through the slide. Yeah. So this is the basic how this does in the electrical system. So electrical system, we have some sensors. That sensor we put in the field, for example, in transformer, in circuit breaker, in bus bar, the thermal sensor, ambient temperature, they sense the temperature or the real time temperature. Then this sensor that goes to the controller. This controller that is basically for monitoring and controlling of this one. And third layer of this one through this artificial intelligence and based on the IoT which is recently added, and this is analytics, advanced analytics, which will say about your equipment, whether it is healthy, how much is life of that equipment, and when you should take the maintenance of that equipment.
Tell me the frequency range on which it is working.
This basically Bluetooth and wireless.
What is the value of frequency for Bluetooth?
This I need to check, sir, because I am electrical student and this is something related to
Your
electronics.
antennas are growing. You should know about the frequency at which they are operating.
Sure, sir. So if you are aware, you can communicate.
2.4 gigahertz.
2.4. Thank you very much, sir. So in power system asset management, these are the equipment. Next. These are the equipment in the field which we can connect through the IoT. Transformer, ST panel, LT panel, bus duct, inverter, drive, motor, pumps, whatever is available inside of the industry, all equipment may be connected to the IoT, through IoT. Next.
How we can control these equipment with the help of wireless signal?
Basically, we can monitor and control. So this is basically based on the eco-structure. So eco-structure basically 3 layers of the system. First layer is the connected equipment. Second layer is monitoring and controlling of that equipment. And third layer is the analytics based on the artificial intelligence which is connected to cloud, through IoT. So if you want to understand in a layman language, you can compare this system with a human being. We have hand, we have leg which are connected to our mind. So this mind monitor and control this equipment, and we, the people who have studied about the subconscious mind, the 5% is our foreign, 95% is subconscious mind. So in subconscious mind we have crore of the picture, thousand of the things, and whatever we will remember it will come. Similar way this AI acts in the system. Artificial intelligence send the alarm alert based on their storage, historian or comparison.
Can we conclude it now?
Yeah, so that was the use case for the transformer. So let's come on 2-3 page. Let's go down how I done this research. So let me.
The basic parameters of transformer.
Yeah, for transformer basically we have the transformer, we have core, we have winding, we have the winding temperature, core temperature, book poles.
What is the material for core?
Sorry.
Material for core.
Yeah, so core silica basically the material for core.
In these days we are using silica.
These days we have advanced material also. Basically this is depend on the no load losses. some material which have the less no load losses, so we use those material.
What are the various losses that occur in the transformer?
Basically two types of no load losses or full load losses. No load losses is the core losses, full load losses are the copper losses.
No load loss.
Yeah, but the iron losses or hysteresis losses, basically no load losses.
Copper loss.
Iron loss and copper.
Defect loss. Hysteresis loss.
So these are come in no load losses. Yeah.
That is your electrical base.
Yeah. Yes. So this is how we can do in a transformer. These are the various sensors. Then it is gone to the controller and monitoring. Then it has gone to third layer through the cloud. That is the IoT, recent technology. Yeah. Go.
The
Next.
transformer is working at a high voltage. Here are our sensors are working at very low voltage.
No. This is not a case. Sensor you can put directly on high voltage also. You can put on 11 kV bus. You can put on 33 kV bus. This will work.
For controlling, we use the low voltage.
For controlling basically, as I said, this is the wireless sensor. If this is your transformer, this will be sensor. This will be our receiver or transmitter. So this signal will come direct here. There won't be any
What is the value
medium.
of the voltage or the current that is produced by the antenna?
That is no antenna. There is no antenna. I said on Bluetooth basis. This work on the Bluetooth principle.
Technology also transmits the signal.
Yeah. So as you said, it may be transmitting in 2.4 gigahertz and the transmitter and receiver.
That is the frequency of the signal.
Yeah.
There will be the value of electric field and magnetic field. Over the base of electric and magnetic field, there will be value of the voltage, current. How much will be the voltage? How much will be the current?
So that would be in millivolt and milliampere.
And your transformer is working at.
Transformer may be 33 by 11, 132 by
How
11.
to manage the transformer with the low voltage?
Basically, the signals are coming to controller and controller is giving to command. One is the control side, one is the power side. Power side is different, control side is different. Whatever you are talking about, high voltage, high current, that is the power side. And we have the control side also. So control side we have the relay, control side we have the sensor which sense the thing for oil temperature, winding temperature. So this sense and they transfer the signal to our controller or monitoring system, maybe SCADA, maybe SAS. Yeah, so that is the dashboard based on the IoT. Next. Yeah, so literature review for this, basically as I said, I use the TAM technology and ELS technology, and based on this technology, IoT enable automation in the real-time analytics, behavior factor, social norms, eco feedback, PU, perceive, use and perceive, age of use.
Why literature review is at the end?
This is my question also.
Basically, I would like to explain the IoT technology because people they don't know specific
Becomes
electrical.
the first thing in the presentation.
The literature review always comes. The first part is the literature review.
Right.
We will see how much work has been done on this topic.
Okay.
On the basis of that topic, we decide our problem.
So first time presenting research paper, so I thought first to go the technically the people will understand the topic, then we'll say about the research. Okay.
So can we conclude now?
So this research, let me this what I have done. So basically, this perceive use and perceive is of use. We have taken the sample from 25 to 35, 35 to 45, 45 to 35. Hypothesis which we prepared this no difference across the group, and second at least one group the show significant difference. Next. Then methodology which
Methodology also comes at the first.
which used as I said, yeah. So maybe the sequence of this, whatever you are expecting from a researcher, so may not be, because as I said, I'm a industry person, industry guy.
But you should keep the sequence.
So,
For the PhD work, no one will give you the PhD
so
based on.
okay, so there was no such guideline that we should have.
There
We
is
should
always
go.
guidelines. You can check
Okay, thank
any
you.
paper.
Will. So methodology which we use for sample, 50 people sample, then 10 plus ELS, 26 item analysis, this is status. I use the ANOVA, Turkey HSD plus T-test for the research.
What is the full form of ANOVA?
I know a full form, not remember, sir.
For what purpose the tests are performed?
Perform on the sample of the 50 people.
ANOVA test or SP?
Yeah. Basically, this is performed to check the difference between the various group. Is there any difference, or we don't have any difference in opinion? Yeah. So key result from 10 this for
Have you used the strategy for making the
not much, little bit.
80%?
Not 80%, because whatever was there, so technically was from mine only for this for TEM or research.
We are
for
actually
skill
running
area.
short of time
Okay,
because
so
scheduled
I have done.
presentations
This
are
is the
delayed.
result and final conclusion that we can use this technology, and the government agency and they can use Make It India through this technology. Okay, thank you. Thanks for the time.
Thank you, Mr. Dev Kumar. So next is paper ID NCET 10.
Thank you, sir. Thank you for feedback.
Go through the guidelines of the research paper, any research throughout the world, any research paper, you can check the guidelines.
Okay, thank you for your feedback.
ANOVA is analysis of variance.
Okay, yeah. Technically, yeah, you are right. Yes, thank you.
It is a test that is performed. ANOVA test.
So now I call upon paper ID NCET 10. The paper title is Leveraging Kaizen Philosophy and IoT Sensor Systems for Defect-Free Smart Automotive. The authors are Nabha Kumar Das and team. So in the meantime, can we start with paper ID 12 if that is ready by Sangeeta Dhal and team? नहीं मिल रहा. 12 is there. So that can be started if Miss Sangeeta Dhal and team is available. I call upon again Sangeeta Dhal and team. Are you available? Please come forward quickly. So this is paper ID, sir, NCET 12. The title is Sensor Embedded Innovative Waste Segregation System by Sangeeta Dhal and team.
Good evening, respected session chair, researchers and delegate fellow. I, Dr. Nisha Yadav from JC Bose University YMCA, present my work on Sensor Embedded Innovative Waste Segregation System.
You are a BTech student or
So I am faculty here.
first slide?
Yes.
Your name and
Actually, this is the format. This is the format provided by the
I think name was there, sir.
Yeah. So let's begin. Ma'am, previous one, starting from the contents. Yeah, okay. So we will start with the contents. First, we will begin with introduction, followed by waste classification. Then we will discuss traditional waste segregation system, proposed model, workflow, and then in the last conclusion. Now, next introduction. So let's begin with what is waste. Waste is anything that is undesired and discarded after primary use. Now, as we all are aware that in India, disposal waste has been increasing rapidly. That is due to urbanization, change in lifestyle, and population increase. So, but unfortunately, what we are seeing that majority of the waste collected, it has been reaching to directly the landfills, and this is due to the lack of efficient segregation system. So this is why effective waste management is critical, because improper waste management, it leads to environmental contamination, toxic emission, foul odor, and significant health is due to vector-borne diseases. It also causes drainage blocking and increased fire hazards in the area where waste is accumulated. So we can say in today's polluted world, learning the correct methods of handling the waste is the main task. And among this, segregation is the most important method. Now, this slide is basically the classification of waste depending upon the composition. Depending upon composition, the waste can be classified into 6 categories, that is biodegradable, or we can say wet waste, which can decompose naturally by microorganisms like leftover food and kitchen waste. Then there is non-biodegradable, which last long in the environment and do not decompose by themselves, like plastic. And the third one is inert waste, and which simply includes the debris from the construction sites and ashes, stones, silt like this. And other 3 classes simply includes e-waste, hazardous waste, and the last one is waste from the path labs. Now, this data pie chart simply represents the composition of.
Have you proposed any model?
Yes, sir. We have proposed the model.
Tell me that model.
Okay, so next slide. This is the traditional waste segregation system in where the municipal garbage collector collect the waste from the household industries, and then it has been transported to the dumping sites where manually pickers sort some amount of waste, and then it has been sent to a turmoil screen where depending upon the whole size it has been segregated. But unfortunately, there is a lack of segregation, and due to that we can see that landfills have been increasing day by day. Now, so in order to overcome this, we proposed a model which simply consists of 5 units. The first one is the input sensing unit. In input sensing unit, there is a simple funnel type structure. It drops the waste on a conveyor belt, and below that there is a heater, and on both the sides there is a array of sensor. First there is a IR sensor. It simply differentiates between a transparent and opaque, like whether it is a glass thin sheet or it is a wood like structure. Then
We need the waste.
why we need?
Why we need the waste?
So just because garbage collected is like accumulated, so just to make it dry so that it can be easily segregated, we provide the heat from the just below the conveyor belt, from the sides of the basically conveyor belts. Then there is a moisture sensor to simply differentiate between biodegradable, or we can say wet or dry waste. Then in the last there is a load cell sensor which will differentiate depending upon the mass of the waste, whether it is a metal waste or lightweight. Then next, the second is the image processing and classification unit. In this, first we have a camera module. It takes the real-time pictures of the waste. Then those images are being pre-processed, like there will be background removal, histogram equalization, and those refined images are sent to the machine learning modules. Now, in those machine learning modules depend upon what they have learned or what we make them train. So depending upon them, it basically assigns label like biodegradable, recyclable and non-recyclable. Then the next part is next is control unit for decision making. This is basically the brain of the our proposed model. In this, we can use a microprocessor. It takes the data from both the sensors and the machine learning tools. And there is a synchronization block. It synchronizes both the data, and accordingly it will intelligently, we can say, it can segregate that whether it is biodegradable, or sometimes there is, we can say, ambiguity situations, because if the waste, let us consider there is a wet waste, so how can we differentiate whether it is biodegradable or non-biodegradable? So there is a control unit. Then depending upon the control unit, it simply actuates the actuators. Then after that, Once the actuators go triggered, there is a mechanical sorting assembly. In this, simply whatever depending upon the data of the machine learning, the type of wastage, the classes of wastage, this has been transported to the different bins. Now either we can use a robot pickup arm for the pick and drop, or we can use a direct DC motor geared flap system.
Thank you. Next one.
Then there's okay. So thank you. Actually, sir, we are thinking of implementing it in Faridabad. We have gone through the site dumping site where. Sure, sir, sure.
मैं स्मार्ट सिटी को लीड करता हूँ फरीदाबाद में 2016 से।
Yes, sir.
मेरा एनजीओ है।
Okay, okay.
मैं सारे आईएएस फरीदाबाद के।
I will contact you, sir.
111
Sir, I will write it down.
भिजवा देना।
Okay, okay. Thank you so much.
So I think now paper ID 10 is also ready. The title is Leveraging Kaizen Philosophy and IoT Sensor Systems for Defect-Free Smart Automotive. And the authors are Nabha Kumar Das and team. So, sir, kindly present it within 5 minutes. We are running short of time.
Okay. Hello. Good evening to every participant, dignitaries. I am N.K. Das, research scholar from North Cap University, and I am going to present my paper that is leveraging how Kaizen can be implemented to enhance the efficiency and operating. This is the way basically my paper will be followed. First of all, actually I will explain about my research problem. Then we'll talk about the literature review detail. Then we'll go for what is the methodology I have used for research. Then data collection, data analysis, conclusion, references. I would request please change the slide. It's not working. This is the background of my research, how these have been motivated. As we all know that since morning we are all talking about the IoT Industry 4.0, and Kaizen is one of the methodology where basically we continuously increase the operational efficiency by involving everyone in the industry, starting from MD to operator. And their involvement, their suggestion, it helps us to bring the increase of our cost reduction, defect reduction and productivity. Next. Please change. This is my research problem. The research problem, see, somehow in the industry, there is a limited understanding. It is about the existing integrating IoT sensor system with the Kaizen for operational and sustainable improvement. In fact, actually, since morning we are talking about the technology change. We all know technology, it is getting disrupted very fast throughout the world. But actually we are really implementing in the industry. And how industry is ready? What is the way they really want to invest in technology? How they want to make their people ready? So my research, I want to understand, if suppose we talk about throughout the globe, Kaizen is a philosophy that is only sustainable for the manufacturing efficiency, and if you want to integrate the Kaizen as well as IoT, then how Indian automobile industry is ready. So based on that, actually I have decided 4 objectives. The first objective is identify the key enablers and challenges which will really help us to identify who to implement the Kaizen. Then assess the impact of IoT and Kaizen integration. Then evaluate the effect of IoT Kaizen integration for sustainable performance, and then propose path according to the way it can be implemented. I request Madam please change. And literature review part, in fact actually I just wanted to explain about the Kaizen, digital Kaizen, IoT, and how it is really helping us, IoT, data analysis and artificial intelligence, to improve our all manufacturing indices. So I am not going to explain much about it because since morning we have already talked about lot. Ma'am, please. Ma'am, please, next also. Here actually one point I like to mention here. Somehow the GDP of India, 7.1% it is contributing the Indian automobile industry. So in fact actually everybody is eyeing on the auto industry of India. In fact, the more it is becoming the global competitiveness, if really they are not working upon the efficiency, cost reduction and global quality level, so ultimately we will not be able to compete globally. So that is why just this point is very, very important, that ultimately traditional method of improving every day and in addition to traditional IoT integration, that is a very, very important. Next is, that already I have discussed. Okay, next, ma'am. Next. Okay. How IoT and our Kaizen integration, it will help. Some of the predictive maintenance, we talk about that. So far what we do it, we traditionally just we wait till the machine actually gets shut down. But suppose actually if we are able to integrate in addition to daily improvement to our technology, that is IoT or sensors based IoT, then all kind of sound that will get captured through the technology and it will help us to know that ultimately when it is to be required maintenance or a parts can be replaced. Similarly, quality control also actually it can be completely digitized feedback. It will help us to complete quality control and energy utilization, smart energy management. So there are so many, if we go on talking about the explanation that how this integration is going to help, there is so many here. Okay, next ma'am. This is the literature review actually I have used for this research. Almost about 71 paper actually I have used it because this particular the topic, it is integration of Kaizen and IoT. So in fact the Kaizen, IoT and Industry 4.0, all the three has to integrate. So that is why you have to go for lengthy number of papers. Okay. And some of the, just I have given a leveling actually how the author have been said. See, they have found a lot of challenges in the industry, how basically when they are going to implement, one way actually the management support, another way motivation of the people, third way the skill of the level of the people. So all these things, it is playing a very vital role for getting it implemented. Ma'am, please. And this is my research methodology. I'll tell you the research actually we have done it survey based question. Okay. Basically I have given to 220 people my paper survey questions. So far I got it 199 actually I have received it. It is a purely non-probability basically method. The reason being I am focusing only Indian automobile industry. But unfortunately so far because of my correction I could only approach to a OEM and bigger industry. Like the Daimler India that is in Chennai based, Maruti Suzuki India that is in Gurgaon based, and Joy Bharat Maruti Limited that is in Pune based. So these three cities have helped me to understand what is the psychology and behavioral concern of the people, how they are really working upon to implement and integrate the IoT as well as Kaizen. These are the enablers we have been able to find it, but enabler means actually which is helping us to get it implemented. Management commitment, employee involvement, training and skill development, technology readiness and vendor support. Here actually once we are talking about the quality, that means it is not only limited to our OEM, it has to go to the entire supply chain. And when we talk about the barrier, that is the most important thing. I am very surprised which was not been even mentioned in our literature review. Time constraint has come one of the biggest actually culprit of to get it implemented Kaizen in Indian automobile industry. Similarly, second is financial barrier, specifically MSME. And when I was talking about the JBML, Joy Bharat Maruti Udyog Limited actually, which is your Pune based, there I found actually financial barrier or cost of technology investment is one of the important barrier, resistance to change, management support, integration data issue. And mediator is IoT Kaizen. But if suppose actually Kaizen, traditional improvement I am going to implement with the IoT, it is helping us to get the result very fast and it will be also given a best quality. then these are the outcome. I will get the operation performance is good, the sustainable performance and defectless smart manufacturing. Ma'am, please.
Can we conclude the PPT?
Ma'am, just 2 or 5 slides more, not very much. Actually, this is a frame based. Actually, it is a,
speed up.
Okay, this is the data which I have collected. It is showing this consistency very good. Actually, if it is more than 7, it is a very good. 0.94. But again, actually, it is only because of 199 data I have received it. Okay, rest of the data I am just still waiting. Ma'am, please can you change the slide? These are the basically barrier which as people have said. Out of 199, 50 people have said time constant is one of the major factors for implementation. Resistance to change, of course, actually skill along with the technology. If our skill is not changing or skill not improving along with the pace of technology change, so it is one of the biggest barriers. Inadequate budget, lack of training and lack of time management support. This is the basically the output. Actually, I tried to implement it in structure equation model. And here basically there are 2 things, exogenous and endogenous independent and dependent variable I have used it. And I have shown it here that suppose this particular data actually I have taken it only for the understanding the defect reduction. So I have taken the data, suggestion system, Hamilton training, Kaizen culture and digital readiness for exogenous and defect reduction is the endogenous or dependent variable. Ma'am, please change. Last slide, please. These are the actual output. See, ultimately the digital ready. Digital is the key mediator. Okay. Ma'am, please just go to the next slide. All the data, because it is a very small data now, data is showing a very encouraging data. That too, most of the data have been taken from OEM. So actual MSME data is still yet to come. Actual figure will get it. Yeah, what is the problem is available. But so far my model fit is very, very good. Okay, next, ma'am. Okay. Again, these are all I have explained the data which I have received it actually. The 92%, how people have said Kaizen training got it or not, how Kaizen activity going on. Okay, whether they are technology ready or not. Please, next. Okay. And key takeaway is high awareness. Training is 33% does not have a formal training. It's one of the very alarming thing for the industry. Second is digital adoption emerging 70% and 30% lagging. But 70% because of actually it is been taken to one of the best factory in India, that is Maruti Suzuki as well as Daimler India. And somehow we have got some views of the JBM. JBM are also one of the component manufacturing company. They have a highest turnover in India. Okay. And just I have shown some of the cases how IoT have been implemented. Those who have implemented, next ma'am, implemented, see how their basically defect reduction is happening. They are almost zero. They are just going to achieve a 6 sigma actually. That is the way they have achieved it. Okay, next. How it will be impact on business very much actually. Defect reduction will be tremendous and operational efficiency as well as actually the global quality it will go up. Next ma'am. Way forward is of course the model is indispensable. If we really can integrate actually our traditional Kaizen as well as to our technology, then it will give us a very good result. Okay, next. Okay. And basically the future research, of course, I am still waiting within the month of December to get all the whatever I have approached to them. If I am getting about 500 survey paper, I think this paper will be able to complete it and I will get the actual data. But that is the way I will be using it, the entire quantified data. It will be total sum-based structure equation model. And this model, if I feel that actually I have been able to convince to our industry partner, so they will get a lot of benefit. Okay, thank you sir, thank you for your patience listening. It is already evening. I think most of the people are getting restless. Okay, thank you very much sir.
Yeah,
Okay,
thank you. I think we need to take a break in between. There's some yeah, actually, can we continue? Okay. So actually they want to proceed with the project competition prize ceremony. Okay.
Good evening. On behalf of Institution of Engineers, Faridabad and Department of Electronics Engineering, Bose University of Science and Technology, YMCA, Faridabad, I extend a warm and heartfelt welcome to all of you to this prestigious project competition, a celebration of innovation, creativity and engineering excellence. It is an honor to welcome Engineer VB Singh, FIE President, IEI, and Dr. Girish Shrikishan, FIE Vice President, IEI, Engineer Indradeep Singh Oberoi, FIE Chairman, Professor Munish Vashisht, FIE Organizing Secretary, Professor Pradeep Kumar Dimri, FIE Convener. For this, I would like to invite our esteemed dignitaries on stage for the prize distribution ceremony. Sir, kindly come on the stage. Now I humbly request our esteemed jury members to kindly join us on the stage. Engineer YP Singh, Director, Kapayo Solutions. Dr. Rajiv Vats, CTO, Technotrend Solution Private Limited.
Rajiv sir. Rajiv sir available नहीं है. Sir Rajiv sir.
राजीव अभी आ रहे हैं.
Engineer Ramakant, Founder and Director, EPIC. Dr. Nitin Sachdeva, Assistant Professor, Bose University of Science and Technology, YMCA, Faridabad. Now the moment we have all been eagerly waiting for, the prize distribution ceremony. The first prize goes to Ankur, Team Dark.
Cash prize of 65.
Cash prize of 6,500.
बेटा तुम्हें बता ट्रैफिक लाइट कंट्रोलर IoT based.
The project title is IoT based traffic light control system.
ये भी है ना दूसरा.
कैश प्राइस भी फर्स्ट पे 5500 Second runner-up is Aman from Team Offload. Cash prize of 5500. Project title is UAV-based portable AKI monitoring system. Second runner-up is Shivam Upadhyay from Team SARS. Cash prize of 4500. Their project title is IoT-enabled EV charging station system. Third runner-up is Khushwant Maurya from Team Arogya Catalyst. Cash prize of 3500. Their project title is IoT-based smart medicine dispenser machine. Thank you all. सर राजीव सर रहते हैं हाँ जी Now I humbly request our esteemed jury member Dr. Rajiv Bose to kindly join us on stage.
जूरी मेंबर रह गए थे राजीव जी कहीं चला
Thank you all.
Thank you.
So now we'll resume back with the technical session 4. We are left with the NCET 67 and NCET 68. I hope 67 number is ready. The paper title is
मैम ऐसे ही कर दो.
नहीं वो सेशन चेयर नहीं बैठे थे ना.
नहीं मतलब
हाँ हाँ.
लेट देम सेट.
So with the permission of session chair,